Greetings, welcome to this new video about nodal analysis or node voltage method. Solve the problem number 10. Let's consider this network consisting of 5 resistors labeled R1 through R5 as well as one independent current source IS and one independent voltage source Vs. The question now is to find the node voltage. Let's move on to the solution. First, let's start by labeling all the nodes in the network, and I will consider this as node 1 and this as node 2. After, we'll assign the voltages V1 and V2 respectively to those two nodes. Next, we need to select a reference node in the circuits. The reference node is typically chosen as the node with the most connections or as the ground node. Let's assign now arbitrarily the currents in each branch, and I will consider I1 is the current through the resistor R1, I2 is the current through the resistor R2, and I3 is the current through the resistor R3, I4 is the current through the resistor R4, and I5 is the current through the resistor R5. Next, we will proceed to apply Kirchhoff's current law in each node. Let's start first with node 1. By applying Kirchhoff's current law at node 1, we can write I1 is equal to I2 plus IS. And if we replace IS with its numerical value, we obtain I1 is equal to I2 plus 0.5. Let's move on to node 2. By applying KCL at node 2, we can write I4 plus I5 is equal to IS plus I3. And if we replace IS with its numerical value, we obtain I4 plus I5 is equal to I3 plus 0.5. And according to Ohm's law, the current can be expressed as the voltage difference across a resistor divided by the resistance. This implies that the currents can be determined by the following equations. I1 is equal to 0 minus V1 over R1. I2 is equal to V1 minus 0 over R2. I3 is equal to 0 minus V2 over R3. And I4 is equal to V2 minus 0 over R4. And I5 is equal to V2 minus Vs over R5. By substituting A and B in 1, we obtain negative V1 over R1 is equal to V1 over R2 plus 0.5. And if we replace the resistors with their numerical values, we obtain negative V1 over 30 is equal to V1 over 60 plus 0.5. And if we combine all the terms of this equation into a single denominator, we obtain the following expression. And if we continue simplifying this expression, we obtain negative 3V1 is equal to 30. That means V1 is equal to negative 30 over 3 is equal to negative 10 volt. By substituting now C, D, and A and E in 2, we can write V2 over R4 plus V2 minus Vs over R5 is equal to negative V2 over R3 plus 0.5. And if we replace the resistors and Vs with their numerical values, we obtain this expression. And if we combine all the terms of this equation into a single denominator, we obtain the following expression. And if we continue simplifying this expression, we obtain 7V2 is equal to 100. That means V2 is equal to 100 over 7 is equal to 14.28 volt. After completing the calculations, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. We can see here this is the independent current source IS the independent voltage source Vs, resistor R1, R2, R3, R4, and R5. I connect here voltmeter to measure the node voltage V1 and here a voltmeter in order to measure the node voltage V2. Let's move on to analysis. This analysis calculate nodal voltages. We can see here V1 is equal to -10 and V2 is equal to 14.29 volt. After completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation results. This serves as a validation or verification of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video about nodal analysis. Take care and bye bye.